Welcome everyone. No introductions today. We will get straight to business. Over to Vijay Kumar sir and Poonam ma'am.
Good afternoon, everyone. Today's session, we start with organic conversion. The focus is going to be on organic conversions. Let me quickly recap what we have done in the previous session. We started with knowing the names, IUPAC and the common names. And we stressed on the common names are more important because that is what is commonly asked in the ICSE, ISE board exams. Not IUPAC names are important, not that IUPAC names are not so important. IUPAC names are important, but the students must be familiar with the common names. So the emphasis should be on common names, was told in the first session. Then the entire fundamental organic chemistry was taken by Poonam ma'am, teaching you all the different types of reactions, the reagents that are used. Basically, the reagents is the one which converts one functional group to another functional group. Then Sarmishta ma'am talked about important named reactions and reagents, all the how to write the name reactions, etc. And also we discussed distinguished type questions. The highlight of the session was Poonam ma'am's flow chart regarding conversions. Everyone felt that was very useful. There were lots of good feedbacks about the Poonam ma'am's and Sarmishta ma'am's session. So with the way forward, I will take the session on conversions. Whatever we have learned in the previous session, it's a continuation of that. This part is the main application part of what we have done in the previous session. Now, I'm going to share my screen and it's going to be a hectic workshop, proper workshop for you. So be ready with your pen and paper and notebooks. I'm going to make you write a lot. Okay. I'm going to share my screen. Tell me if my screen is, whiteboard is visible to you. I'm sharing my screen now, so everyone
sounds good.
Can see my whiteboard?
Yes.
Fine. Now, I start up with types of organic reaction. This is my methodology of introducing organic chemistry to my students. I classify the organic reactions into some 7 or 8 types of organic reactions. Are you all ready with the pen and paper? I hope you're all ready with a pen and paper. So when I introduce the type of organic reaction, this is most important. The reason is when a particular conversion is given, the student must know what type of reaction is that. When the type of reaction comes to his mind, automatically the student will start thinking about the reagent part. Fine. Now, on that note, I'm not going to go very slowly like how I used to do in the school. You're all teachers. There are some few senior teachers are there in this meeting. So it will be a little boredom for them if I go very slowly. So I will try to go a little faster. But at the same time, if any one of you find it, you are not able to go, understand whatever I am doing, you please pause me and ask me questions then and there, so that I will clarify that part for you and then go for the next one. The first type is substitution type reactions. First type is substitution type reactions. In the substitution type reactions, I'm going to introduce all the main substitution reactions in organic chemistry, ISE 11 and 12 organic chemistry. Starting with the first reagent is chlorine and UV. This is a very good substitution reagent. So if you take methane, write chlorine on the arrow mark in the presence of UV, right? This will be converted to methyl chloride. The hydrogen of the alkane is getting substituted by a chlorine. Then you take ethane, the same chlorine UV, you get ethyl chloride. Okay. Here, since our aim is to teach the basic organic chemistry to the students, we don't have to talk about further chlorination. What are all the different types of chlorination products? No. Please tell the students that one hydrogen is substituted by the chlorine. And here, you don't have to write the side product HCl at all. Teach them these basic things. This is what is conventional organic chemistry is all about. Write the reactant on the arrow mark, whatever the conditions, reagents, everything on the arrow mark, the product side you have to write. First, teach this fundamental organic chemistry to the student. Then whatever is required for the ISC board examination, writing the side product, balancing the chemical equation, that and all can be understood later. But stress upon this. Here, hydrogen is getting substituted by chlorine, and whenever one of the hydrogen of an alkane is going to be substituted by the chlorine, chlorine and UV is the reagent. Please stress upon that. Number 2, aqueous KOH. Once you get methyl chloride or ethyl chloride, I will write RCl. R can be methyl or ethyl. RCl, you add aqueous KOH. Aqueous KOH, you get ROH. R can be any alkyl group. Okay. What is isopropyl chloride? One of you please unmute and answer. Someone please. Isopropyl chloride. If R is isopropyl chloride, I'm going to treat you like my students and I'm going to ask you questions. Please respond. Isopropyl chloride.
C3H7Cl.
Sampa ma'am, you cannot say C3H7Cl for isopropyl. The moment you condense this formula, this can be for CH3, CH2, CH2. Also the same is for CH3, CH and CH3. Then how come you can teach your student to C3H7? You cannot. You
Sorry,
have to,
Yes.
It will be
You have-
CH3Cl.
exactly CH3. This is what is isopropyl chloride. So when you write the reactant as isopropyl chloride, then you write isopropyl alcohol here. Isopropyl alcohol here. The reagent is aqueous KOH. The same reagent will come. Whether it is methyl, ethyl, isopropyl chloride, whatever it is, if the Cl is going to be substituted by OH, then the reagent is aqueous KOH. Okay. Now, next. Then next, third reagent. Alcoholic silver nitrate. Now, if you notice, most of the substitution reactions come in haloalkanes and haloarenes chapter. CH3Cl, alcoholic AgNO2, this will be converted to CH3NO2. Whether it is, if it's ethyl chloride in the place there, alcoholic AgNO2, the reagents is what we need to remember. This is what our Poonam ma'am was stressing in the last session. The Cl is changing to NO2. Then ammonia is a very good reagent. Ammonia, you can add ammonia as a reagent. RCl, add NH3, RNH2, a primary amine. RNH2 primary amine. A ethyl chloride, ammonia, you get ethyl amine. Ethyl chloride, add ammonia, you get ethyl amine. CH3, CH2, NH2. Here, everywhere can you see there is a substitution is happening. Cl goes, NO2 comes, Cl goes, NH2 comes, like that. Are you all keeping in pace with me? Or you all able to write as much faster as and when I write? Or should I slow down a bit or something? Can I get the responses?
We are able to write.
Yes,
It's
it
fine.
is fine.
It's fine.
It's fine. Now, NH3. Then HNO2 is another good substitution react. HNO2 is a very good reagent where RNH2. Whenever you have RNH2, you put just HNO2 on the arrow mark, you get ROH. This is what we expect from the students. Write the reactions, write the product, write the reagent on the arrow mark. And you should know that amine is going to be substituted by alcohol. Amine is replaced by alcohol. Fine. Okay. Okay. Next reagent I add is not exactly a substitution type of reaction, but I want you to understand that whenever we want to replace just one functional group to another functional group, RNO2, SnHCl, TnHCl, you become RNH2. Yes, it is a reducing agent. The what is the reaction that is occurring is going to be a reduction reaction, no doubt about that. But we can classify all these things in the substitution because NO2 goes and NH2 comes into here. So these are all the conversion of, these are all some of the important substitution. Then the most important PCl3, PCl5, SOCl2, all are chlorinating reagents. What they do, they convert ROH to RCl. Anyone you can add, whichever is your favorite you can add. My favorite is PCl5. You choose your favorite chlorinating reagent, you will get the substitution type reactions. So overall, in the 4 chapters of organic chemistry, when we teach some 100 or 150 odd reactions to our students, when we consolidate them, finally we will end up only like 7 or 8 reaction in the substitution category, not more than that. It was a surprise even for me. When I categorized this into different types of reaction, I found that I need to learn only 8 reagents. It was a surprise for me, but that is what is there in overall organic chemistry. Fine. Did I cover all the substitution? If I miss out anything, you can also tell me, sir, this can it also be included or something like that? Poonam ma'am, if I miss out anything, please tell me. In substitution, these are all the chlorine, UV, aqueous KOH, alcoholic AgNO2, NH3, HNO2, SnHCl, PCl5. Only these are all the substitution reaction as far as I know in our syllabus. Then I move on to the second type. Quickly, I will go through these different types. After substitution, what you need to teach to your students is addition type reaction. Addition type reaction.
Excuse me, sir.
Yeah. Yes, madam. Want to ask something?
Excuse me.
Yes. Jayanti ma'am, we can hear you. Please go ahead.
Sir, alcoholic KCN.
I will not introduce that here, madam. There is a reason for that. I will introduce that as a surprise package, like during the conversion. I will introduce. This is what yes, alcoholic casein can also be introduced here, but I don't want to bring that here. It is having a specific purpose. That alcoholic casein is having a specific purpose, so I am just hiding it from my students. Okay.
Okay.
Thank you for telling that, ma'am. We will have that. Definitely we'll have that. In addition reaction, please tell your students in the addition reaction, a pi bonded substance is going to be the reactant. In the addition reaction, a pi bonded substance is going to be the reactant. It can be an alkene, it can be an alkyne, it can be a cyanide. Cyanide contains a C triple bond N. So we can do addition reaction even to a cyanide, a carbonyl compound, an aldehyde, ketone, a ketone, etc. These are the various reagents where mainly there is a double bond. So we can classify the 2 atoms that carries the double bond, A and B, or A and B, there is a triple bond. You are going to add something to this. What will happen during the addition? Suppose, instead of A and B, let me put C double bond C and C triple bond C. When you add A and B to this, AB to this, what will happen during addition reaction? A will go and add to one carbon, B will go and add to another carbon. The double bond will become a single bond. So C, A is attached, double bond becomes a single bond, C, B is attached to it. Now, the same AB, if you are adding to a triple bonded carbon, what will happen? The triple bond will become a double bond. Triple bond will become a double bond and A and B will be attached. Now, during addition reaction, a very important rule we need to remember, Markov-Nichols rule. Okay. Now, please tell your students where this Markov-Nichols rule will apply. This rule will apply. This rule will apply when the pi system, pi system we use as reactant is unsymmetrical. Reactant is unsymmetrical. Also, the reagent what we use, the addition reagent what we use is also unsymmetrical. See, where to use the rule becomes very, very important. We all know Markov-Nichols rule. We all are teaching Markov-Nichols rule. But where this Markov-Nichols rule will apply? Markov-Nichols rule cannot apply when you have a ethene, CH2, double bond CH2, you add HBr. Here Markov-Nichols rule need not apply. Here the Markov-Nichols rule need because this is a symmetrical alkene. The addition reagent might be unsymmetrical, but it doesn't matter because the alkene, what you're adding is CH2H, CH2Br. It doesn't matter. You change Br here, H here. It doesn't matter. The alkene or alkyne also must be unsymmetrical. The reagent also must be unsymmetrical. Then only we need to talk about the Markov-Nichols rule. You know what is Markov-Nichols rule. I don't have to explain to you teachers what is Markov-Nichols rule is. Anyone here, please convey the Markov-Nichols rule to the entire audience. How will you, because Markov-Nichols rule varies from teacher to teacher, from textbook to textbook. So please, you give your opinion of Markov-Nichols rule.
Sir, I think according to Markov-Nichols rule, the negative part of the attacking reagent goes to the carbon with lesser number of hydrogen atoms.
Perfect, Monica ma'am. Perfect. It goes to the carbon containing lesser number of hydrogen. But for this rule to apply, the alkene also must be unsymmetrical.
Yes.
The reagent must also be unsymmetrical. Suppose the alkene is unsymmetrical. Okay. Now the reagent is H2. What is the point? Here, this H can be, one H can be added to this carbon, another H can be added to another carbon. We don't have to differentiate, no, in the case of homoatomic molecules. You understand? Here we need not to talk about the Markov-Nichols rule at all. Then Markov-Nichols rule will apply only when we have a propene and HBr. Here atoms are different, heteroatomic, here unsymmetrical. Then your negative part and all apply. See, what I want to convey to you teachers is, we teachers think, oh, all these are very, very simple things. Markov-Nichols rule I am learning from +2, BSc, MSc, everything. I'm teaching for 10 years, 20 years. What is so difficult in that? See, for teachers, it might be easy. But for the student, your class 11, class 12 student who is hearing that for the first time, for him, this is wow, something I am going to learn today. Like that, with that feel only the student is going to sit in the class. So every minute detail you tell to him becomes much more important for him. It is not that whether you know the subject matters there. As a teacher, we all know the subject. How we deliver the lecture in front of the students, that matters the most. We have to use our words carefully. See, all these are very, very important points when we teach addition reaction. Alkene, alkyne, teach cyanide will also undergo, cyanides will also undergo addition reaction. For example, when I say CH3, C triple bond N, it's a reduction reaction. We add a lithium aluminum hydride and we add 4 nascent hydrogen. What happens? 2 such nascent hydrogens are added to this carbon, 2 such nascent hydrogens are added to the nitrogen. So in that case, the triple bond, when 2 atoms are added to this carbon and 2 atoms are added to the nitrogen, it becomes ethylamine. Ethylamine. We need to convey this to the students. Yes, yeah, that's not, is the addition reaction does not happen to carbonyls. When we have acetaldehyde, and we add HCN, when we add HCN, isn't it H plus the CN minus? Isn't this H plus and CN minus? Don't we call this as nucleophilic addition reaction? This carbon carries a delta positive, this oxygen carries a delta negative due to electromagnetic effect. So the positive charge of the hydrogen goes and added to this oxygen, the negative charge sign, it goes and adds to this carbon. And the double bond becomes immediately, the double bond becomes a single bond. So when you teach this much detailing, your student will tell you, the moment he sees, he looks at the C double bond O, he knows it is a pi system, HCN, nucleophilic addition, electrophilic addition and all. Later, mechanistic based chemistry. But at least the student will know, since there is a double bonded system, C double bond O, there is a pi system, and we are adding some reagent, it is a type of addition reaction. The CN minus will go and add it to the carbon, the H plus will go and add it to the oxygen, and most importantly, when 2 such atoms or 2 such groups are added to the 2 atoms of the double bonded system, the double bonded system will become a single bond. This information must be given very clearly, like hitting the nail hard. We need to hit it so hard in the heart and the mind of the student so that the student comprehends the subject. Fine, I stop addition reaction here. And you teach about Markovnikov. You please teach about anti-Markovnikov also. Anti-Markovnikov. For anti-Markovnikov, you say the same propene, I add HBr and peroxide. Propene, HBr, peroxide. I will get anti-Markovnikov rule. This time, my HBr will go to the carbon containing more hydrogens, like that. And all our textbooks gives organic peroxide, as if the reaction will not work with hydrogen peroxide. All these are misconceptions. Whatever, we should not follow the textbook straight away. So, is it going to be only with organic peroxide anti-Markovnikov rule applies? No, it even works with a simple hydrogen peroxide. One textbook author writes about organic peroxide, every other people copy that. Let's not have this copy pasting mentality. We should use our original thinking. Read good textbooks. Morrison and Boyd, Claydon, those books gives you very clear clarity. What to be used, what not to be used, like that. So with this, I stop addition reaction. Any questions regarding addition reaction? Any questions? Should I cap any questions, or should I continue this?
No, sir, no questions.
Thank you. Now the third type of reaction I want to introduce is elimination type reaction. Opposite of addition. Immediately, once you teach addition, immediately you teach elimination. And this thing, whatever I am discussing with you, must be done when you start hydrocarbon chapter for your 11th standard. Once you complete a basic organic chemistry, IUPAC, reaction mechanism, carbocation, carbanion, all those intermediates, everything, before you start hydrocarbon, this portion, whatever I am discussing today, must be clearly told to your students, so that only after this session, you should start teaching your reaction after reaction after reaction after reaction, whatever is given in our great ISE syllabus. Now, in the elimination reactions, please note, make a note, tell your children, in any elimination reaction, in any comparison, we can compare and learn. In any elimination reaction, the product is going to be an unsaturated system. The product is going to be an unsaturated system. In any elimination reaction, so example, your product is going to be an alkene or an alkyne. I'm not going to stress too much on alkene, alkyne. I'm going to stress too much on alkyne. See, in addition reaction, please, we have to start with the double bonded system. In an elimination reaction, opposite of addition, we'll end up with alkene or an alkyne. Our focus, let it be only on, and during this elimination, there, because alkene and alkyne are there, minimum there has to be 2 carbon. Minimum there has to be 2 carbon. In one carbon, you are going to have your functional group like a halogen, and in another carbon you are going to be, this is called alpha carbon, this is called beta carbon, and all our eliminations are beta hydrogen elimination reaction. Please tell all these things to your students. Beta hydrogen elimination. Beta hydrogen means alpha carbon is the carbon that contains the functional group, and beta carbon is the beta hydrogen is the hydrogen that is present in the beta carbon, and beta carbon is the carbon that is next to the functional group carbon. And now, to make an alkene, only there are 2 reagents. Only there are 2 reagents to make an alkene. In the entire organic chemistry of CBSE and ISC syllabus, we can have only these 2. Nothing else to make an alkene. CH2, double bond, CH2. Alcoholic AOH brings it, that's all. You don't teach them that H and X are going, K, all those things, all those side product business are unwanted in the beginning. Let our children enjoy proper organic chemistry. Let our children enjoy the conventional organic chemistry, which you and me enjoyed during our undergraduate and postgraduate days. Don't frighten our children with this balancing equation, balancing organic chemistry, and writing the side product. Please remove the fear of balancing the equation and writing the side product. Don't pressurize them in the beginning itself by giving those unwanted side products. Just because it is the side products are asked in the board exam questions, it doesn't mean that children should be denied the fun of learning organic chemistry. Organic chemistry is the most easiest chemistry, where if this methodology is adopted, you will enjoy teaching organic chemistry. Students will enjoy learning organic chemistry. And only 2. One is alcoholic AOH. We call this as dehydrohalogenation reaction. Please don't talk about E1, E2 mechanism, S1, all these are unwanted. Just tell them what is elimination. Then this is one of the reaction, then dehydrohalogenation and dehydration. Dehydration. Again, beta hydrogen elimination. Again, beta hydrogen elimination. Ethanol, ethyl alcohol kind of thing, concentrated sulfuric acid, 170 degrees Celsius, you end up with an ethene. So basically, only 2 reactions are there in elimination. One is alcoholic AOH, concentrated sulfuric acid. Tell your children that whenever an alkene is required, we need to use any one of these 2 reagents. If it is an alcohol, go for concentrated sulfuric acid. If it is a haloalkane, we have to use alcoholic AOH, the best dehydrohalogenating reagent. Only these 2. The student should not think there are so many 100, 100 and 200 reactions. We should make the subject simplified to the students. That is what is my earnest plea to all the teachers present here. Make the subject so easy for your students. This is only 2 elimination, substitution, addition, elimination over. And when we talk about elimination, we need to talk about Seitz's rule. Don't forget, Seitz's rule. Seitz's rule. Seitz's rule. I want to know what are all the different versions of Seitz's rule prevailing here in the market, ISC market. Anyone, please?
Sir, I always give this: poor becomes poorer. Poor becomes poorer. That is the easy way to remember. Poor becomes poorer.
That is Poonam ma'am's what you call punch dialogue. Poonam ma'am's famous dialogues. Poor becomes poorer. Anyone else, please? Anyone else? Please come on, share. If at all, otherwise I will be only talking. I always talk too much.
Anyone?
Hey, if you are not talking, I'm going to ask you, make you talk. Okay. Shubhangi ma'am, please go ahead with your style of sides of rule.
Hello.
Anyone? Vidya ma'am, please.
I see that there are
Sir,
27 of us.
I'm not taking ISE. I'm taking only ICSE. But whatever I learned from MSc, the double bond will go to more substituted alkyl carbon, right?
The double bond is most stable alkene will be formed as the major product. That is one version of, see, most substituted alkene. This is what is actual Sage of talks about. Most substituted alkene is formed as the major product. Okay. Now, what you need to do is when you say this big statement of most substituted alkene is formed as the major product, here the student will ask, what is the most substituted alkene? The student does not know what is the most substituted alkene. We as teachers know which is the most substituted alkene. Okay, so we can say compared to butene, butene is more substituted. But see here, the point is what they mean by more substituted is, if in an ethene there are 4 hydrogens. In an ethene, the double bonded carbon. These are the double bonded carbon. Here 2 hydrogen, here 2 hydrogen. Suppose if one of the hydrogen is substituted by a methyl group, it is one substituted alkene. Like one of the hydrogen is substituted by a methyl. Now, if this carbon, if both the carbons are substituted by a methyl group, this is two methyl substituted alkene. So this is what is meant by more substituted alkene. Look at the carbons. Suppose in the case of butene and butene, this is your 1 butene. Now there are 3 hydrogen. Only 1 hydrogen of an alkene is getting substituted, whereas this is what is your butene. Now 2 of the hydrogens are substituted, but to comprehend this, an ISE student, 11th standard ISE student, will take a long time.
Excuse me, sir.
Yes, ma'am.
Excuse me, sir. We can't see the
Yes.
screen.
I think others are able to see the screen.
Yeah, we can see the screen now.
Yes, sir, it's
No problem.
visible.
Yes, sir, we can
Can
see.
you
Yes,
just
yes.
check?
Sir, we can see.
Can you just
Just refresh it, ma'am, or something. You can able to see this.
Okay.
Fine.
or maybe even quit the meeting and join back. That might help.
All right, sir. Thank you so much.
Fine. Now, what Poonam ma'am taught, Poonam ma'am is talking with her students is very famous statement, like poor becomes poorer. Okay, she did not highlight the actual thing, but this is a punch dialogue. See, we teachers are more like superheroes, no? We are more than Rajinikanth, Amitabh Bachchan, and Kamal Hassan. We should be much more prouder than those cine actors. We should make our own punch dialogues. For me, Poonam ma'am is a superstar, right? When Poonam ma'am says, for sides of poor becomes poorer, I enjoy each and every letter written in that. That's because what she is telling is, when you have a 2-chlorobutane, and do alcoholic KOH, this is an alpha. Now you have 2 beta. This is beta 1 and beta 2. Okay. Now between these 2 betas, beta 1 and beta 2, who is poor in hydrogen? Here, this fellow is having only 2 hydrogen. This fellow is having 3 hydrogen. So this fellow is poor. This fellow is already poor. Beta 1 is already poor. So Sides of talks about take the hydrogen from the poor fellow. Take the hydrogen from the poor fellow. So the beta 1 is eliminated. CH3, CH, double bond CH and CH3. Rich fellow B2 does not give hydrogen. Poor fellow gives the hydrogen. That's what Poonam ma'am's statement. Poor becomes poorer. See, In the other way, I will say the hydrogen is, see we can always compare the Markovnikov and Markov means addition reaction and the elimination reaction. In addition reaction, where you are adding the negative part, you are adding the negative part to negative part of the reagent to the carbon containing less hydrogen. Here, so while removing also, remove from the lesser hydrogen, remove the hydrogen from the less substituted beta carbon. Now, Vijay Kumar sir talks about remove the hydrogen from the less substituted beta carbon. Poonam ma'am, our superstar, talks about punctudialogues, poor becomes poorer. Now, here, Shubhangi ma'am, Monica ma'am, Karthikeyan sir, Shailaja ma'am, you create your own punctudialogues.
Sir,
You make
excuse me, sir.
it. Yes.
Sir, what I used to do here, I used to make them to write both the products. From both the beta 1, you have to remove, and beta 2. And from that, more number of alpha hydrogen will be more stable. From the product, number of alpha hydrogen which is more, that will be the most stable product. Like that I used to tell.
Perfect, ma'am. Perfect. But see,
Yes, sir.
at the end of the day, your children must be enjoying your chemistry classes. That's all. That's all.
Yes.
Fine.
Okay.
So
Okay.
when we talk about elimination, SPEF becomes important. So what are the reactions we have completed? Substitution, addition, elimination. Okay, I'm sorry. Now fine. I'll go to my next type of reaction. Next type of reaction is oxidation. Oxidation is an integral part. If you remember, I don't want to spend too much time on oxidation. Last class itself, ma'am talked about alcohol changing to aldehyde, changing to carboxylic acid. You remember Poonam ma'am's presentation? It is there. It's there very clearly given. Aldehyde, carboxylic acid. What I will just add to this thing is oxidizing reagents. What we are using in our ISC, I want to specify that. PCC, pyridinium chlorochromate, concentrated HNO3, K2Cr2O7/H plus, acidified dichromate, KMNO4/H plus, acidified potassium permanganate. These are the only oxidizing agents. CBSE talks about chromium oxide in sulfuric acid and all. That is CBSE. We don't want to include chromium oxide and all. Our ISC board never asks the different types of oxidizing agents. We stick on to PCC, concentrated nitric acid, dichromate acidified, permanganate acidified. In that, I will say PCC is a mild oxidizing agent. What it can do is, it can only convert a primary alcohol to aldehyde and a secondary alcohol to ketone. That's all it can do. It cannot do anything else. A PCC can only convert a primary alcohol to aldehyde and a secondary alcohol to ketone. It cannot do. I will say concentrated nitric acid as miscellaneous. According to me, a highly concentrated mineral acid is not a very great oxidizing agent when it comes to organic compounds. Yes, it can be used as an organic, it can be used as a proper oxidizing agent in your inorganic metals. Copper will be converted to copper nitrate, zinc can be converted to zinc nitrate, sulfur can be converted to sulfuric acid. It's a mineral acid. Why unnecessary I need to bring it? Any R&D labs, I worked in organic R&D labs for 5 years. I have never seen concentrated nitric acid used as an oxidizing agent in the real world. See, what we teach should be practically applicable also. How we can say that just for getting mark in ISC and CBSE, I will teach you concentrated nitric acid. By chance, if one of our student learns organic chemistry and enters into the PhD field, and he goes and happily says that concentrated nitric acid will do the oxidation purpose of an organic compound, the doctorate person will ask you, our student, from whom you learned organic chemistry. Do we want such embarrassing situations? what we teach must be, and what we ask the questions also must be practically applicable. I will tell you one thing. I just want to add these points in the discussion forum. See, in coordination chemistry, we are asking IUPAC names. We just like that make central metal ion, whatever the ligands of our own interest we are adding. Whatever the ligands, cyanide, carbonate, so much ligand we can add, whatever we want. Our contemporary board, CBSE, will ask questions only from those coordination compounds which actually exist. They will not ask anything, any imaginative coordination compounds. Yes, theoretically, such imaginative coordination compounds do exist, but in the exam, they will never ask such questions. So I don't know how come concentrated nitric acid becomes a very important oxidizing agent only for our ISE chemistry, which should be avoided. Fine, and that's why I say that's miscellaneous. Okay, acidified dichromate and acidified permanganate are strong oxidizing agents. Strong oxidizing agents. Strong oxidizing agents. So please remember that PCC, and note, PCC cannot be used for oxidizing, cannot be used for oxidizing aldehyde and ketone. Aldehyde and ketone. So give this list. Now give them some example. How to teach the reactions here? Give them methanol, PCC, put nascent oxygen below that, telling that it's 1 carbon alcohol, so it will be changed to 1 carbon aldehyde. Methanol to formaldehyde. Finished. Organic reaction over. Finished. This is what you need to teach in the beginning of the organic chemistry. Let the students enjoy. Let the students enjoy. Ethyl alcohol. Ethyl alcohol. I want to use strong oxidizing agent, sir. Acidified dichromate. What will happen? Being a strong oxidizing agent, ethyl alcohol converts this to ethanoic acid. Okay, and the funny part is ethyl alcohol, acidified dichromate, controlled nascent oxygen. It means it becomes acetaldehyde. This is what is given in our answer. This is what is given in our answer case. By writing controlled in the whiteboard or by writing controlled in the paper, does it mean in the original organic reaction, the reaction will be automatically controlled? Or does you and me is actually going to perform the reaction in the reactor? The moment you put acidified dichromate, ethyl alcohol, it's going to be converted to ethanoic acid. So don't teach such reactions. Don't. These are all my own perceptions. Don't make them write control, but it is accepted. This is accepted in ISE. This is accepted in ISE. That is why I'm bringing all these discussions here. So you can use strong oxidizing agent, right? By writing controlled, our ISE people believe that the reaction can be controlled and ethyl alcohol can be converted to acetaldehyde. But according to me, ethyl alcohol will not be controlled. It will go directly to ethanoic acid. So we need to use, that's where we need to use mild oxidizing agents. Now, acetone. Acetone is an oxidize. Acetone, a ketone is very difficult to oxidize. But this difficult ketone that is going to be oxidized will be oxidized to acetic acid. Acetic acid by using concentrated nitric acid. Always for oxidation, put a nascent oxygen. Put nascent oxygen. So these are all the things which I want to talk regarding oxidation. Then elimination. Oxidation, reduction. Reduction. Same thing. Reverse of oxidation is reduction. See, like how addition and elimination you are correlating. Similarly, you relate oxidation and reduction. Reducing agents. Don't talk about various reducing agents that exist. Only talk about these two. NaBH4, LiLH4. NaBH4 is mild reducing agent. NaBH4 is mild reducing agent. Lithium aluminum hydride is a strong reducing agent. Strong reducing agent. What will happen here? RCOOH, LiLH4, you will end up with a primary alcohol. Aldehyde, mild is NF. Wherever mild can be used, in the place of mild, you can use a strong. Nothing wrong. But in the place where a strong has to be used, you cannot use a mild reducing agent. So NaBH4 cannot reduce a carboxylic acid. RCOOH, reducing agent only, but it's a mild. This reaction cannot occur. NaBH4, RCH2OH, RCH2OH. This reaction cannot occur because it's a mild. So where you need to use the mild, you can use a strong reducing agent, but where you need to use a strong reducing agent, you cannot use a mild reducing agent. Please tell all these things clearly to your students.
Sir, here also there is a small trick which I
Yes,
always
madam.
use. It is,
Please.
nowadays in politics, we have this Aam Aadmi Party. So I always use that Aam Aadmi Party. So acid, aldehyde, and primary alcohol. So always you can do that. AAP. So acid, aldehyde, primary alcohol. That order, if the children remember, many conversions they can do easily.
Exactly.
Aam Aadmi Party. If you tell them Aam Aadmi Party, they will not forget.
Thank you, ma'am. Thank you, ma'am, for that. Fine. Now, up reducing reduction. So that's all introduction. That's all you have introduction. You don't have to talk too many things about. Now, what we are doing is actually, we are telling our children, beta, organic chemistry is very easy. Come on, just let's learn and have fun. Only this many reagents are there. This many reactions are there. So our students will start enjoying organic chemistry. Then slowly, we can, once they started enjoying this, they will ask you, ma'am, give me more conversion. We will do. The moment your students start enjoying organic chemistry, when they start asking you to give conversions, you have done your part. Fine. Oxidation, reduction. According to me, substitution, addition, elimination, reduction is my fifth type. My sixth type is condensation type reactions. Condensation type reactions. Many reactions in organic chemistry are condensation type. What is the note here? Note here. Two compounds can be coupled together by condensing and eliminating small molecules like what? H2O and H. I'll write Cl because most HCl. H2O and HCl. Try to write the second compound in such a way it is easy to recognize the small molecule that is eliminated. Try to write the second compound in such a way it is easy to recognize. It's easy to recognize the small compound. For example, we always come across reaction with acetyl chloride. In our ISC syllabus, many places acetylations are there. Alcohol acetylation, phenol acetylation, amine acetylation, aniline acetylation. So many places reaction with acetyl chloride is there. For example, our ethyl alcohol reacting with acetyl chloride. Write ethyl alcohol in the first place. The acetyl chloride can be written like this in the reverse way. Cl, C double bond O, CH3. Now what will happen? This H and this Cl are removed. H and Cl are removed. Minus HCl. If you want, you put and write that as a side product. All those are your way of teaching. Now what will be remaining? Once you remove the H and Cl, you start from this end, come up to here, start from here and come up to here. Just couple them together. Show this arrow mark, show these lines. Student must know what to couple with what. Right up to here, then just connect them together because HCl is now removed. We call these as box diagrams, right? Box diagrams. It can escape. Yes, madam. Monica ma'am, please go ahead. You are talking, we can hear you. Okay, fine. She's lagging. When she wants to ask, let her ask. So this is how you need
Sorry,
to.
sir, I didn't realize I was unmute.
Okay, fine. Fine. Tell me, ma'am. Fine. So many such condensation reactions are there. Okay. Reactions of here more condensation reactions are reactions of aldehydes and ketones with ammonia derivatives. Ammonia derivatives is a very important type of condensation reactions, but not many questions are asked in ISC. But when we learned in our undergraduate degree, this part has become very, very important part, right? We write our acetaldehyde, CH3C. See, I will write it in such a way, double bond O, which is coming on the right side. Then when I combine my hydrazine or phenyl hydrazine, I want to, why I am writing my acetaldehyde, the double bond O suddenly over here, just to show that this O and H2 are removed. Then what is left out? Up to here, my bond is there, and then combining with this. So I start from this end, CH3, CH, then there is a double bond. Then you have to come to this nitrogen, then NH, then a phenyl group. Easy for the students to write the structure by the condensation. So the key for the condensation is the way in which we draw the structure. The way in which we draw the structure is the key for condensation type reactions. So with this, all my types of reactions are over. In fact, when you go to aromatic, suppose if at all you want, you talk about substitution, addition, elimination, oxidation, reduction, condensation. Yes. Seventh type, aromatic type reactions. The moment you say aromatic, you talk about EAS, electrophilic aromatic substitution. Electrophilic aromatic substitution. Mainly nitration, sulfonation, bromination, and chlorination. Nitration, sulfonation, bromination, and chlorination. Friedel-Crafts alkylation and acylation is only there in the syllabus, only for anisole. No other place they have Friedel-Crafts alkylation and acylation. So we have only nitration, sulfonation, bromination, and chlorination. Now, what will happen generally? Each one has a reagent, right? So you all know this. You take benzene. Please write concentrated nitric acid and concentrated sulfuric acid only on the arrow mark. Only on the arrow mark. So we get nitrobenzene. Not at all like how we expect in the final board exam. Please don't teach these what we are going to write in the final board exam in the beginning of the academic year. In the beginning, let the student enjoy learning organic chemistry. The organic chemistry is fun. So make them enjoy organic chemistry first. Benzene, concentrated sulfuric acid. Concentrated sulfuric acid. We get benzene sulfonic acid. Benzene. Okay. Teach them all these things. See, here most of you, everyone is a teacher here. So you know what all these things. But why I am retelling all these stories to you is, this is the way you need to introduce organic chemistry for your students. This is the way I introduce organic chemistry for my students. So take benzene, nitrobenzene, benzene, aromark, sulfuric acid, consulfuric acid, benzene sulfonic acid, benzene, FeBr3, Br2, bromobenzene. Wonderful. Now tell your children that in benzene, all the hydrogens are same. In benzene, all the hydrogens are same. So it does not matter when you add concentrated nitric acid and concentrated sulfuric acid. Any one of these hydrogen is replaced. It doesn't matter. So out of the 6 hydrogen, any one is going to be replaced. So one of them is going to be replaced. Electrophilic aromatic substitution. But it matters a lot. It matters a lot when there is a group sitting over here. When there is a group. According to this group, these 2 positions are called as ortho positions. These 2 positions are called as meta positions. And this 2, the opposite position is called a para position. So based on the group G, if I do a nitration, if I do concentrated nitric acid and concentrated sulfuric acid, okay, I can get G nitro in the ortho position and G nitro in the para position, or G is a meta-directing group. G is a meta-directing group. So NO2 comes in the meta position. So G can be an ortho-para director and G can be meta-director. Most of the time, our children ask us, sir, ma'am, how to decide which group is ortho-para and meta? I was teaching in a different way. Later, a few years back, I think, yes, during the lockdown, I think, one of the teacher who is attending this meeting, Mrs. Vidya, she's there, I think, or I don't know whether she left. She told me, Vijay sir, it's very simple. If G contains only a single atom, G contains only a single atom or single bonds. G contains only a single atom or single bonds, then it is ortho-para. If G contains double bond, the group G contains double bond, then it is meta. A very simple solution for the whole lot of ortho and para and meta. Thank you, Vidya ma'am. I asked, Vidya ma'am said, Vidya ma'am's brother is an organic chemist, means he is a professor in Tamil Nadu college now. Vidya ma'am said her brother taught this technique, simple technique to her. Who taught her brother? One of his college university professors in Tiruchi, Bharathidasan University. See, this is what is legacy of organic chemistry means. One good professor teaches one good thing, that learning comes to another person, that learning goes to another person. See, when that Bharathidasan University professor taught Mr. Mohan, Vidya's brother, he doesn't know, after some 20 years, we will be thinking about that great professor who taught Mr. Mohan this simple technique of single bonded compounds and double bonded compounds. Later, after 25 years, Vijay Kumar sitting in Chennai is talking to entire bunch of chemistry teachers across India, the same thing which has been taught in one corner part of Tamil Nadu. Poor becomes poorer is told in this meeting by Poonam ma'am. Later, how many of us are going to use that for our entire lifetime? And our own students going to take that legacy of organic chemistry throughout their life, if at all they are going to pursue chemistry as their career. So this is how we should be passionate about a subject. This is what our passion towards the subject will carry forward to the students. The irony is, with all the modern day inventions, new technologies are coming. There are very rare our children are taking chemistry as a career. After some 10-20 years, there won't be any chemistry teachers at all. Teaching chemistry is going to become very difficult. It's not easy. It's not going to be easy job. There won't be anybody teaching chemistry nowadays. In Europe, there are no good chemistry teachers. Means there are number of teachers are less. I'm not saying there are no teachers. The number of teachers are less in Europe. So that's why they recruit people from India, China, Bangladesh, Pakistan. Pakistan produces excellent teachers. And all the teachers are working across the globe. Okay, so this is how organic chemistry legacy should be carried forward. Thanks, thanks that great professor. Thanks, Mr. Mohan. Thank you, Vidya, for teaching me that, so that I am telling that to all the people, all the teachers in this forum. So my first part of organic chemistry is over. Any questions? I need a 5 minutes break. Someone can intervene so that I can start with my conversion after this 5 minutes break.
Right, sir.
You can ask questions now.
Yeah, you can ask your question. Sir, you take a minute, 5 minutes, sir.
Thank you, Vijay sir, for remembering those things, and in the correct time you are telling. Thank you so much.
Anybody else? Those who have questions, you're more than welcome. Feel free. I think most of you were not here. Those who joined at about 2:25 today, we were discussing. We were just telling hello to each other, introducing each other. So if you don't have questions, maybe you can do that. We'll give Vijay sir about 5 minutes.
Sir, I have a question.
Yeah, just hold on. Let me just see that one of them is online. Poonam ma'am, are you there?
Please go on with your question.
Yeah, go ahead. Go ahead.
Ma'am, my question is, sir, just now, a few moments back, sir said that for the oxidation reactions, we need to mention only the mild oxidizing agent as NaBH4 and the stronger oxidizing agent as LiLH4, lithium aluminum.
Reducing, that is reducing agents.
Yeah, sorry, reducing agents, yes. So, but then do we actually need to mention at all the nickel, platinum, hydrogen, those catalytic reagents?
See, the platinum and hydrogen or nickel and hydrogen, they are definitely very good multi-purpose reducing agents.
Yeah.
But the problem with those reducing agents is that, how they reduce. They reduce by, let me just share my screen and show you. See, they reduce, how they reduce is by adsorbing hydrogen on their surface. So supposing this is your, catalyst, nickel, or whatever it is. So platinum, palladium, and nickel, these three have a great ability to adsorb hydrogen. So finely divided nickel on the surface of it, you pass what? Hydrogen gas. So hydrogen gas, what happens is it gets trapped on the surface like this. Hydrogen gets trapped on the surface, right?
Yes.
So when it gets trapped on the surface, then you pass the alkene. Say, for example, you pass CH2 over it. So since hydrogen is trapped, it picks up hydrogen from the surface of the catalyst. That is how it reduces. So for this, the reagent should be stable in its vapor phase. The reagent has to be passed, the vapors of the reactant have to be passed over the catalyst and hydrogen.
Yes.
So if the reactant is not stable in its vapor phase, then you can't reduce by this method. So that is why it is a specific hydrogen and nickel and platinum or palladium. they work specially for alkenes and alkynes, which are most of them in lower alkenes and alkynes, they are gases, naturally gases in their natural state. So they can be reduced very easily. Hydrogen and nickel does not always work. But lithium aluminum hydride and sodium borohydride, they work in a different way. Their mechanism is very different. So they actually work across the double bond. So that is one advantage of using those reagents.
So that is more universal, that is lithium aluminum.
Lithium aluminum hydride is one of the best reducing agents because it can reduce all oxygen. First of all, it reduces by addition of hydrogen, and all compounds which have oxygen in their functional group, they are reduced to aldehydes, to alcohols, and all compounds which have nitrogen in their functional group, they are reduced to amines. So many of them.
Yes.
So that is why lithium aluminum hydride is a very useful one.
Oh, thank you so much, ma'am.
Yeah.
Any other questions? I'm ready to take the questions.
I think, sir, I suggest maybe another thing we can do is as we go on, the participants who are here, there are about 30 of us, you can just write your questions down and, you can still ask at the end of the session. Huh? Just make sure that a question pops into your head. It's important that you write it down because there is a good chance that you might forget it. So good to just pen it down. And then if nobody else want to ask a question now, I think we'll proceed.
Okay, let me proceed with that, or let me proceed further. So now I'm going to the main part of organic chemistry, which is conversions. So I start with one carbon conversion. Okay, there are different, we introduced the types of reactions. Here we have types of conversions. First type is 7 types are there. Remember that. One carbon conversion. Here, okay. At the end, you can take a screenshot of all these things. When I draw, it might be difficult for you to comprehend, means go draw along with me. So in methane, you take one carbon only, so you take only methane, add chlorine UV. See, whatever the reagents we have learned there, substitution, conversion, everything is going to be presented here in the form of conversion. So methane, chlorine UV, substitution will happen. So methyl chloride. Add aqueous KOH is going to be methyl alcohol. Probably I will start from this end. Methane, chlorine UV, methyl chloride, aqueous KOH, one carbon conversion. You get methyl alcohol. Add PCC. Whenever I add PCC, nascent oxygen, methyl alcohol is converted to formaldehyde. Formaldehyde, acidified dichromate and nascent oxygen. Acidified dichromate and nascent oxygen, formic acid. A linear conversion in one carbon. This is the only way you can do that linear conversion. Methane, methyl chloride, methanol, formaldehyde, formic acid. Then another route. Alcoholic AgNO2. This will become CH3NO2. Add tin and HCl. This becomes methylamine. Add HNO2. This becomes methanol. So this is another branched conversion. Methyl chloride, nitromethane, methylamine, methanol. Formic acid to methyl alcohol. Reverse is also important. Lithium, aluminium hydride, nascent hydrogen. Methanol to methyl chloride is important. Any one of the chlorinating agent, I will use PCl5. That's all, one carbon conversion. That's all you can make. I have brought in all the 4 functional group. Chloroalkynes is brought out. Alcohols are here. Carbonyls are here. Nitro compounds are here. Over. All the 4 chapters are here in front of your screen. and only this many, these are the reagents, main reagents, yeah, 11 and 12 student must know in ISC class. You cannot say we have, sir, you have ignored some reagents. No, you using this flow chart, any conversion can be done in an easy way. Can I go to the next step? Next step. Yes. Second type, 2 carbon conversions. When I say 2 carbon, I mean ether. See here, if you can see, everywhere I have only 1 carbon. Methane, methyl chloride, methanol, formaldehyde, formic acid, nitromethane, methylamine, everything is meth. Now here comes 2 carbon conversions. 2 carbon conversion, you need to start from here. I need to start from this place. Quickly, the common name of this compound. Someone in the group, common name of this compound.
Acetylene.
Acetylene. Acetylene. Hydrogen nickel, we get ethene. Because in 2 carbon conversion, we have to be little careful because in 2 carbons, we have alkynes and alkenes, and they are very important for us. And someone was asking about hydrogen and nickel. I use hydrogen and nickel, particularly for gaseous hydrocarbons. Reduction, same reduction, but gaseous hydrocarbon I use. Ethane. Now, here also now going to be the same story. Chlorine UV, ethyl chloride, aqueous KOH, ethyl alcohol, PCC, nascent oxygen, acetaldehyde, acidified dichromate, acetic acid. Another linear conversion, the same story, alcoholic AgNO2, CH3, CH2, NO2, tin HCl. What will happen tin HCl if you add to your nitroethane?
It will become NH2.
NH2, HNO2, ethanol. Now reverses, possibly reverses. Acetic acid to ethyl alcohol, LiAlH4. This to this, PCl5. Now, I have some special conversions to be mentioned here. Because if I complicate this flow chart, it becomes too complicated. I don't want to complicate it. But 3 conversion I want to specify here. Very important. Dilute H2SO4, HgSO4, acetaldehyde. And my 2 elimination reactions, I'll bring it here. My 2 eliminations reactions, I'll bring here. Ethanol.
Excuse me, sir. Can you use next page? It will be.
No, I want to complete that. Oh, you are not able to see? You are not able to see here?
No. I am able to see. No problem.
Yeah, fine. 3 more conversion I want to add here. CH triple bond CH, because I want to finish all the 2 carbon in 1 page, so that if someone wants to take a screenshot or something, they can have it in the same page. Dilute sulfuric acid, acetaldehyde, my ethyl alcohol, concentrated sulfuric acid, ethene, CH211 CH2, my chloroethane, alcoholic KOH. These 3 also belong to the 2 carbon conversion, making the 2 alkane and converting the alkyne directly to an acetaldehyde. Now, after you give the chart to this, you should ask them, give them the flow chart, ask your students to do the conversion. Looking at the flow chart, let them do the conversion first. Okay, let me go quickly ask someone here in the group itself. how will you convert a nitroethane to acetaldehyde? How will you convert a nitroethane to acetaldehyde?
Convert.
Yes, ma'am. Go ahead.
Yeah,
Yes, ma'am.
sir, we first convert it to amine by 10HCl, then to the alcohol by HNO2, and then by adding HNO2, and then oxidize it to acetaldehyde by adding PCC.
Perfect, ma'am. Perfect, ma'am. Now convert acetic acid to nitroethane. Someone, acetic acid to nitroethane.
Acetic acid, reduce it to alcohol. And alcohol to halide.
Perfect.
And then halide to nitro group.
Perfect, ma'am. Perfect. Now, see, by looking at it, for teachers, it becomes very easy. Now, what we need to ask the students is, ask them to frame the questions themselves. See, looking at it, it's like a map, Google map. Google map takes us from one place to another place, right? Like that. Now, one of you who has not opened your mouth so far, please frame a conversion here now. Frame a conversion, ask someone else a question. Ask Anand sir a question, let Anand sir answer. Anand sir is a physics student here for us. Let us see whether our teaching organic chemistry has gone to Anand sir.
I'm sorry. I am sorry, I wasn't paying attention. Anyway, but I will still take the question if there is any.
Yes, sir, please.
So Anand, how will you convert acetic acid to ethylamine?
Oh, no,
You have to follow the chart, Anand. From acetic acid to come to ethyl alcohol to ethyl chloride, and then nitroethane, and then ethylamine.
yeah.
So follow the
last time I studied chemistry was when you taught me that 20 years ago.
yeah.
So, huh?
No.
So
Yes.
I may even count the C of the chlorine into the as one of the carbon atoms. That's how bad I am. So
Okay, fine. Someone else, please be participative.
Vijay Kumar sir.
Yes.
Hello. Vijay
Yes.
Kumar sir. A small suggestion. Can we use ammonia for converting ethyl chloride to ethylamine directly?
Perfect, sir. Perfect. See, I don't want to add too many things. Like what you are saying is it will reduce to 2 steps. From the 2 step, it will reduce, like what sir is telling is put a line like that. But putting a line here makes this flowchart a mess. Karthikeyan sir, you are perfectly correct. That's the way.
Sir, but I have one suggestion here. See, what I would suggest is that it is better to do this way, because when you are converting ethyl chloride to ethylamine using ammonia, then there are multiple products possible, right? There are multiple products possible. So to prevent the formation of multiple products, you can go this way. Otherwise, you will get ethylamine, and then you will get diethylamine, and then you will get triethylamine. So wherever there are multiple products possible, choose those methods where multiple products are not there. Like, for example, here also, I would rather take ethene here and convert ethene to ethyl chloride by adding HCl. By addition of HCl, I would convert ethene to ethyl chloride, because if I start from ethane, then I will get not just ethyl chloride, I will get multiple products. But this is more refining it. I mean, like, it depends on how your children are following it. Once they become comfortable with this, then you can give them many more suggestions. In fact, they themselves will tell you hundreds of ways of doing the same thing, right?
Exactly.
You can even, like, if you want to do via ethene, you can write here hydrogen, palladium and barium sulfate. Use Blinder's catalyst so that you get only ethene. And from ethene, you add HCl, you get only ethyl chloride. And then you get only. So there are some advantages for each method. So whenever a student suggests a method, you should always say, yes, it is possible. But why the other one is better also, if you tell them, then they will be convinced. That is it.
Perfect.
Thank you, ma'am. Thank you, Vijay sir.
Fine. Quickly, can I, if you are not going to frame a question, I am going to move on for the third conversion, third type.
Yes, sir.
Yes. Okay, fine. Okay, fine. Let me go to the third condition. Third, all my Zoom pages are exhausted. I have to go back to my first page. Third, 3-carbon conversion. 3-carbon conversions. In 3-carbon conversion, very interesting, very, very interesting 3-carbon conversion. I use only specific methods in 3-carbon. In 3-carbon, my propene takes a special place for me. Why in 3-carbon I make propene? Because I may start with 1 propanol or 2 propanol. Okay. What I do, I can add concentrated sulfuric acid, 170 degrees Celsius heating. I will end up with propane. Similarly, I can start with 1 chloropropane, which is N-propyl chloride, 1 chloropropane, or 2 chloropropane, which is the isopropyl chloride. I can do my alcoholic KOH. I can add my alcoholic KOH. I will end up with my propane. Now, the moment I get into propane, I have 2 ways. If I add only HBr, I will get my isopropyl bromide here. I add my HBr and my peroxide, HBr and peroxide. I will get my 1-bromopropane here. So to change the position from 1 to 2 or 2 to 1, these conversions are excellent conversions of changing the position of the functional group from 1 to 2 or 2 to 1. And once you get here, you can add aqueous KOH. You can add aqueous KOH here. You can add aqueous KOH. Okay, fine. 1 bromopropane or 2 bromopropane. So this is the main. So conversion from 1 to 2. For example, how will you convert 1 chloropropane to 2 bromopropane? Someone else answer, please. How will you convert 1 chloropropane to 2 bromopropane?
First, dehydrohalogenation, sir, alcoholic KOH.
Yes, ma'am.
Then just add HBr.
HBr. Okay. You start from 2 propanol and end up with a N-propyl bromide. Someone else, please. 2 propanol to 1 bro. Yes.
Dehydration
by using concentrated H2SO4 followed by addition of HBr, Kharash effect, peroxide effect.
Exactly, ma'am. So we can use this 3-carbon conversions mainly on this aspect, and then from here, see, in fact, we can start from propanol and end with propanol. 2 propanol to 1 propanol. How will you do this? 2 propanol to 1 propanol. How will you do this? I want 2. You start with the 2 isopropyl alcohol. You start with isopropyl alcohol. End with isopropyl alcohol, end with the N-propyl alcohol. Someone? Yes.
Sir, isopropyl alcohol, we first dehydrate with concentrated sulfuric acid. We get propene, and then we add HBr in the presence of peroxide. We get 1 bromopropane, and then we add aqueous NaOH or aqueous KOH. We get 1 propyl alcohol. That is
perfect, ma'am. Perfect. Enjoying your conversions. Okay. So with that, we can convert to 2 to 1, 1 to 2, 1 to 1, like 1 bromopropane to 2 bromopropane, or 2 bromopropane to 1 bromopropane. We can just mismatch that. And then once you get isopropyl alcohol, I want to stress upon that. I'll erase this part because once you get this 2 bromopropane, which is isopropyl bromide, I want you to add aqueous KOH here. You get isopropyl alcohol, and then don't forget our friend acetone. But otherwise we never take we cannot use acetone in our, we will never bring in acetone. So PCC, nascent oxygen, we have acetone. Acetone. Now the acetone can be converted back to isopropyl alcohol and isopropyl. Acetone to isopropyl alcohol, you use NaBH4. So remember, whenever we get it, whenever we get the functional group in the second position, there is more chance to get converted to isopropyl alcohol, which all oxidation goes to acetone. And acetone we end up with isopropyl alcohol, which is 2 position. From isopropyl alcohol, we can end up with any of the position. Now, one difficult conversion, let me check who can answer. Acetone to 1-chloropropane. Acetone to 1-chloropropane. Conversion
sir,
is...
reduce it. Sir, first reduce it using sodium borohydride.
Yes, madam.
Propane to wall and then dehydrate with concentrated sulfuric acid and then HBr peroxide.
No, we want 1-chloropropane, but.
Okay, HBr peroxide, then okay, HBr, I will get 1-bromopropane.
So convert it,
sir,
1-bromopropane to alcohol.
Or alcohol to, okay, we can do one thing, sir. Convert bromo to alcohol and then SOCl2.
Very good.
Exactly. Okay, fine. Because see, this HBr peroxide thing will not work for chlorination.
Yeah, chlorination number.
It will not
only
work.
in HBr, yes, sir.
Only in HBr. So that's why I gave 1-chloropropane. Just think about it, how effectively you can do such conversions. But this is how you need to introduce conversions like 1 carbon, 2 carbon, 3 carbon. Now, I don't have any extra page. I'll go to my first page quickly and clear all in the first page. Addition of what you call is ascendance, increasing by 1 carbon. Fourth type of conversion is increase by 1 carbon. Increase by 1 carbon. How I can increase? How I can increase?
Stepping up also, we can call it stepping up.
I increase by 1 carbon. Now, make a note here. Somehow, tell your students the same, somehow reach alkyl chloride specifically. Somehow reach alkyl chloride, or alkyl halide is fine, but getting alkyl chloride. If the conversion starts with alkyl chloride, then fine. But somehow reach alkyl chloride. Because the moment you reach alkyl chloride, which is your RCl, now you introduce your alcoholic potassium cyanide. One of our teachers asked me this question in the beginning of their class. Sir, CN, alcoholic potassium cyanide substitution, yes, it's a substitution reaction, but very special reaction for increasing my carbon. R, C, triple bond N. Along with my R, by adding my potassium cyanide, I have added 1 carbon here. Now, what is the further conversion? Acid hydrolysis of this, complete acid hydrolysis of this goes to carboxylic acid of any this thing, or then you use sodium and ethanol. This is another reducing agent. Why I did not introduce in the reagent? Because there I want to minimize. There I want to tell my children only about lithium aluminum iodide and sodium boride. Now, after my children knows little bit more, after my students know a little bit more, I am giving sodium and ethanol also, nascent hydrogen. I'll end up with RCH2NH2. And then my RCH2NH2, I can add my nitrous acid, HNO2 kind of things, and that you convert it to alcohol. So this is my main aim. This note is very important to be given to the students. So whatever they give, try to convert it to an alkyl chloride, then it is easy to increase by 1 carbon. There are very rarely some other method available to increase your carbon. This is the most common and the most used method. Grignard method is there, but we will keep Grignard reaction separately. Teach your students in the beginning this kind of conversions. How to increase? Convert it to RCl, alkyl chloride. Then you can increase one carbon. Now let me see. I want you to convert formic acid to acetic acid. See, in the beginning, let them use this simple method. Later, they can think of shortcut methods, reducing the number of steps. But in the beginning, if your children do these methods, I'll be very happy. How will you do this formic acid to acetic acid? Anyone, please.
The formic acid, we first reduce to alcohol, that is methanol. Then methanol, we change it to methyl chloride by adding PCl5. Then we step up by adding alcoholic ACN. And so it gives you ethyl cyanide, methyl cyanide, and then we first it gives methyl cyanide, and then we reduce it to ethylamine by adding LiLH4. Okay, and then we oxidize it, then we change it to ethyl alcohol by adding HNO2, and then we oxidize to acetic acid by adding
fine. But that's a little longer step. Once you get cyanide, you can do the acid hydrolysis directly.
Yes,
no?
acid hydrolysis. Yes.
See, yes. You get the methyl cyanide, right? CH3CN. Yes. You do the acid hydrolysis, you go to acetic acid.
Yes.
So the main idea is to get to that alkyl halide part.
Yes.
Okay. So another conversion, but only very few teachers are talking. I can see Girija ma'am talking now. The ma'am who spoke just now, the same ma'am is giving the answers. What about others? There are 30 odd people. Yes, thank you, ma'am. Yes, ma'am. Papia ma'am. Thank you. Now I'll give one more conversion. You try this, okay? Ethyl amine to N-propylamine. Someone please try this conversion. Ethylamine to N-propylamine.
Ethylamine. Shall I, sir? Ethylamine.
Yes, ma'am.
With HNO2, ethyl alcohol. Then we have to convert into halide, ethyl chloride. Then on treating with alcoholic potassium cyanide, we will get RCl. That means propyl cyanide, CH3, CH2, C, which on complete hydrolysis will get propanolic acid.
Fine, thank you, ma'am. Excellent. Then, ma'am, but I have one clarification. So here, I could sense that some, sir, is there a problem? Yes. Now here, this CH3Cl, I could say that our teachers are not telling the correct name. CH3CN is methyl cyanide, but it has 2 carbon. So the IUPAC name of which is ethane nitrile. And when you have CH3CH2CN, this cannot be called as propyl cyanide. You cannot call this as propyl cyanide. This is ethyl cyanide.
Propyl nitrate.
Ethyl cyanide. If you want to see use the IUPAC name, then it is propane nitrile. The cyanide carbon is included in the functional group. Okay, so that we need to stress here to our children. Then the common name is only 1 carbon, but the IUPAC name contains 2 carbon. It's a very special case. For us teachers, it might be easy, but for the students, they are learning it for the first time. We have to stress it upon to them. That's all in increase of carbon. I'll move on to decrease. We call this a step-up conversion. Step-up conversion. Then step-down conversion. Step-down conversion. 5th type. Step-down conversion. Step-down conversion. Decrease by 1 carbon. So here again, the note what we give is an important note. What is a note? Somehow reach to carboxylic acid. The only method to decrease the carbon. See, these are all the things which we need to tell our children. There is no other code to step up, step down, unless you reach to carboxylic acid. RCOOH. RCOOH. Add sodium hydroxide. You get, there are two methods. Add NaOH, acid-base reaction will occur. We get RCOONA. Then you use your sodium hydroxide, calcium oxide, and heating, soda lime reaction, RH. We end up with an alkane. The next one is add ammonia. You get RCOO minus NH4, ammonium alkylate, ammonium carboxylate, COO minus and N plus. Then heat this. R means we can make this as a single step also. Unnecessary 2 steps. We don't have to tell the children in the beginning. Ammonia heating. RC double bond O NH2. Then our famous Huffman bromide reaction. Huffman bromide degradation. Bromine KOH and heating. RNH2. RNH2. But the idea is somehow we need to reach carboxylic acid. Unless we reach carboxylic acid, we cannot reach. We cannot do step down.
There's
And
one
only
Hans
meter-
Decker also, sir. Hans Decker.
Ma'am, Hans Decker, the problem is, for that also you need a sodium, a silver acetate. You need a carboxylic acid. You need a carboxylic acid. Then you treat that with, convert it to a silver, yeah. So the carboxylic acid is the most important one. Okay, and Hans Decker reaction we don't use much in our normal conventional conversions. Okay, and our famous question in our ISE board is convert ethylamine to methylamine. This question has come 3 times so far in ISE. Ethylamine to methylamine. Do this. Someone please do this. I please someone else, like shall I call up the name? Shalini ma'am. Ruby ma'am, anyone, Joy ma'am, please. Daniel, there is one male staff, Mr. Daniel, please go ahead. Anyone else? Ethylamine to methylamine. Why silence so far? Anyone else, please? Yes, sir, please. Yes, sir, please.
Ethylamine. When we use nitrous acid, we will be getting ethyl alcohol. Ethyl alcohol, when we use, when it undergoes oxidation, we will be getting acetic acid. Acetic acid, when we use ammonia, we will be getting acetamide. Then from acetamide, when we use Br2 KOH, we will be using, we will be getting methylamine.
Perfect, sir. Perfect. Perfect. You teach the same way to your students. They get full mark.
Sir,
Fine, these are
please, all of you, please remember, you should emphasize that when you're writing ammonia, you have to heat. If you just write ammonia and don't write heat, then you don't get marks for that step, right? So it is important to write heat. And otherwise, if you are more comfortable writing the 2 steps, then better write 2 steps, but don't forget to write heat, right?
This one, this is what his ma'am is talking about.
Yeah. So they have to write, mention heat, just ammonia is not enough.
Fine, fine. So this is a step down type conversion. We have completed all the major types. Now the sixth one is the famous Grignard reaction in conversions. Grignard reaction in conversions. Okay, yeah, in our alcohol phenol chapter, they specifically talk about this type of conversion. These conversions convert the following. Very specific. Convert the following. One type of alcohol to another type of alcohol. Methanol to ethanol. Though it looks step up, but step up will take a long process. Ethanol to isopropyl alcohol. It's like methanol to primary alcohol. Primary alcohol, ethyl alcohol to secondary alcohol, isopropyl alcohol. These are the famous conversions with respect to Grignard. Isopropyl alcohol to tertiary butyl alcohol. And Grignard to carboxylic acid. So these are the general conversions involving Grignard reagent. Okay. This methanol to ethanol. In Grignard, remember, methanol, you do the oxidation with the PCC, and for PCC, it goes to formaldehyde. Formaldehyde you treat with Grignard followed by hydrolysis. I will write all the steps here, including the intermediate. Formaldehyde is an unsaturated system. Nucleophilic addition will occur. So carbon here is negative, magnesium is positive. So the negatively charged methyl group adds to the carbon and the positively charged magnesium adds to this oxygen. So we get HCH, CH3 added over there, OMGBr. OMGBr is an intermediate, and always an unstable intermediate is written within a square bracket. See, such importance is not at all given there in our answer keys also sometimes. The intermediate must be written in a square bracket. We are teaching organic chemistry only, right? We have to tell them what is an intermediate, what is a stable compound, etc. And then acid hydrolysis of this. We are giving too much importance for the few numbers. 2 KOH, 3 KOH, 5 chloroform, 6 iodoform, all those things. But wherever chemistry has to be taught, we are not giving importance to the actual chemistry. These are all some of the flaws which we need to accept and change. CH3, CH2, OH. So what here is done? First oxidize the given alcohol to a formaldehyde, acetaldehyde, acetone, whatever it is. Then you do your Grignard, CH3 MgBr. You end up with a ethyl alcohol. Now you start with ethanol also, the same methodology you need to follow. Start with ethanol also, you need to follow the same methodology. If you start with it, I'll write it in the next page. How will you do this? Ethanol to isopropyl alcohol, summon. Similar with the Grignard. Ethanol to isopropyl alcohol using Grignard. Shortcut method. Primary to secondary. Someone please.
Ethanol and oxidation. Oxidation, acetaldehyde. Acetaldehyde with Grignard reagent. Afterwards, acid hydrolysis. They'll get secondary alcohol.
You can do like this also. In the conversion, it is allowed actually like this. Without writing the intermediate, you can put 1 methyl magnesium bromide to acid hydrolysis. If you know, if a student's after well versed, they can go and write it like this. It is step up using Grignard, but also primary to secondary. You know, can you see that it follows a methodology? And this is very much specified in the syllabus. Ethanol to isopropyl alcohol. Now, someone isopropyl alcohol to tertiary butyl alcohol in a very similar methodology. Someone else, please.
Isopropyl alcohol. Isopropyl alcohol on oxidation with PCC will get acetone. Then Grignard reagent, water hydrolysis, I will get tertiary alcohol.
Tertiary butyl alcohol. Thank you. Thank you, Vidya ma'am. Perfect. Tertiary butyl alcohol. And another place where Grignard becomes very famous is, okay, no one would have thought about the carbon dioxide, which we teach in the 11th standard as C double bond O, C double bond O. The carbon dioxide, which actually has a linear structure of C double bond O, C double bond O, can be used to make a carboxylic acid. Okay, people who are the scientist who has done this reaction must be a very brilliant person. The same logic. Same logic. Single, double, the moment the two things are added, double bond will become a single bond. OMGBr, CH3, double bond O. But it's an intermediate, unstable intermediate, square bracket. Do the acid hydrolysis to get acetic acid. Don't write a side product at all now here. Later, if when you're after your children become a master in organic chemistry, then you tell them to write the side products. Your teacher will tell, why ma'am, you are torturing with us by writing side products? Your students will ask this question to you. We enjoyed organic chemistry in the beginning. Now you are making us to forget organic chemistry by writing side product and balancing equation. Okay. Now these are the Grignard conversions. The last one conversion
Excuse me, can you
yes.
Visit the previous page where you converted methanol to ethanol?
Same
Just
thing.
I'm noting down I'm taking the snapshots. So I need to.
Sure, madam. Please do that.
Methanol to ethanol conversion, I think previous page.
This one, ma'am, methanol to ethanol only here. I mean the methanol to ethanol.
Yeah. That's done, sir. Thank you.
Okay, the last conversions are aromatic conversions. In the beginning itself, we have discussed about the ortho-para director and meta director. So in aromatic conversions, main hero is diazotization. Okay, diazotization. Fine, I'll write all those reactions here. In main aromatic conversion, they generally start with the nitrobenzene. Nitrobenzene, you use tin and HCl, you get aniline. Aniline, you do this diazotization, NaNO2, HCl, 0 to 5 degrees Celsius, benzene diazonium chloride. Benzene diazonium chloride. And then once you get benzene diazonium chloride, you can convert it to whatever you want. H3PO2, Cu plus and heating, you get benzene. You add steam, water and heat it, steam, you get phenol. Okay, you do this Sandmeyer's cuprous chloride and HCl. You get chlorobenzene, Sandmeyer-Gattermann, Sandmeyer reaction I have written. And there is one reaction, specific reaction, HBF4, then convert to nitrobenzene, everything. These are the one thing. And another famous conversion is, please do remember, phenol, chlorobenzene, sodium hydroxide, 623 Kelvin, 200 to 300 atmospheres. Sodium phenoxide, dilute HCl, phenol, zinc dust to benzene. Generally, and then one more important conversion is when you have toluene, you have this ETAD reaction which is mentioned in your syllabus. Toluene, one chromyl chloride, 2 water, you get benzaldehyde. These are some of the important conversions that can be asked in aromatic conversions. Then you have all the name reactions involved in conversions, all these things. Now, once you teach all these conversions, within this, see what we have done in the last 2 hours, to be very precise, 2:30 to 4:30. We have done all the important reactions. We have covered all the important reactions in the 4 main organic chapters: haloalkanes, alcohols, phenols, carbonyls, and organic nitrogen compound. By teaching this, most of the 90% of organic chemistry is over. And how long will it take to teach all these things? Remember to start with the in the group I shared the important common names and IUPAC names. I have shared in all the groups, ISC group, SPEF group, everywhere. First, make them learn and make them write a test in the names. And then whatever Poonam ma'am has taught, then whatever I have taught today, everything you club together, it will take 2 weeks or just, let us say 12 to 2 weeks or 3 weeks time. Let's say 3 weeks, 15 classes, 15 periods. But by spending 3 weeks time towards the end of 11th standard, you are making organic chemistry the most beautiful and enjoyable subject for the student for the next 1 year. Please try this out. This method works out beautifully. It works out. And then you start teaching your hydrocarbon, haloalkane, haloarine. You give reactions after reactions with the balancing number, focused on balancing number, memorizing balancing number, whatever you want you do. But the children will say organic chemistry is good. Now, with this, my part is over. Poonam ma'am is ready to share some questions with you with all these conversions.
Poonam ma'am, your video is off. Poonam ma'am?
Yes. Yeah. Okay, so based on what sir has done, these are a few types of questions which are asked. So these are called roadmap questions. So I'll share the PPT with you, but you can see now all of you can answer along. I mean, like there is no problem. So how will you convert acetic acid to, this is about converting. This is a mixture, like sir has classified them into 7 different types. So mixing all of them together in a jumble, I have mixed and then I have produced this. So once the children are confident with those 7 types, which are very important, give them enough practice with the 7 types, and then you can come out with these roadmaps. So now, by now, they have already become thorough with the reagent, so they will not find it difficult. So tell me, what reagent should I use to convert acetic acid to acetyl chloride?
PCl5.
Yeah,
PCl5.
Yeah. So you can use PCl5. Then how can I convert acetyl chloride to acetamide?
Ammonia.
Yeah, ammonia. So this step could have been done in a single step with ammonia and heating, but since it's a roadmap, they have already defined the road, so you have to just tell the reagent. So what will I do here? C is what?
Bromine,
Hoffman
bromide.
Yeah.
Degradation.
Yeah. So like that, I have prepared a few of this roadmap. So I'm not going to spend time in going through each one of them. I think all of you will be able to answer knowing the names of reagents that we have just discussed. So this is 1, this is 2, this is 3, this is 4. So all these different types of roadmap questions you should practice with the children. I will send it to you. You can make many, many more and share with everyone. If everyone makes some 4 or 5 roadmap questions and shares it on the group, we can have a exhaustive list of roadmap questions and all the students will be benefited. So that is one. Then this is another type of roadmap question where your reagent is given and you have to identify A, B, C, D. What is A, what is B, what is C, what is D. So that also is very helpful. So I have prepared some. This is the mixture of, type 1, type 2, type 3, what sir has told, but you can choose all these, use all these and try to figure out what are the products and help. This will also help the children to remember the names of reagents. And these are the type of questions which are asked in the exams. Many of them I have picked up from the old question papers. Okay, so these are some of them, 10 I have made here. Now, this is the third type, which once their grasp over chemistry has become strong, then only you should start making them do this type of questions, which are organic, you can call them organic numericals, or solving or finding the structures of compounds based on properties. So how they link it. So here the properties which they pick up for the compound, they are specific to that compound. So these are all from, believe it or not, they are all from old question papers. Okay. Some of them, I can even tell you the year, but I don't remember all. But this is, say, for example, an alkene A is subjected to ozonolysis to give two compounds B and C. So you must advise the children to read the whole question carefully, and wherever they are able to see some reaction which they are familiar with, they should note down, then build it on the left, build it on the right, and they'll be able to find the final product. So see, on reaction with Grignard reagent, B gives a primary alcohol. Now, which compound? First of all, you should know that on ozonolysis, the compounds B and C which are given, they are carbonyl compounds, because the product of Grignard reagent is always carbonyl compounds. Okay, so it has to be an aldehyde or a ketone. Now, what gives you a primary alcohol with Grignard reagent? You should know. So there's only one aldehyde which gives you primary alcohol. All other aldehyde give you secondary. Only one aldehyde gives you primary. Which is that aldehyde?
Formaldehyde.
Formaldehyde. So B is formaldehyde. So it is CH2 double bond O or HCHO, whichever way you like. Then C gives a positive iodoform test on reduction, and C gives a primary alcohol. So C gives a primary alcohol. Gives a positive on reduction. So the C is acetaldehyde.
Ma'am, I have a question here, ma'am.
Yeah.
In the paper, if they identify by names also, they'll be given marks. If they don't,
they have to just write. They have to They don't have to show how. They have to just write what is A, B, C, and D. If they know it, they just write it. There's only marks for writing the name. Sometimes to be on the safer side, don't write the structure. You write name. Write both rather. Formaldehyde, and this is acetaldehyde, right? Once you have identified formaldehyde and acetaldehyde, alkene A becomes easy. What is alkene A? It is propene, right? So there are some such questions which are there. So we can, here again, everybody can make, we have 250 teachers. So if you can make, 2 questions each, you get 500 word equation reaction. So that is, that will really help. Make simple ones first, and then you go to more complicated ones. So this is one. Now similarly, there is this one, an aromatic compound C7H6O. Sometimes the formula is given. So here, what you have to emphasize to the children is that when you see the percentage of carbon appearing to be very high in comparison to hydrogen, then you know that it is an aromatic compound, right? So yeah, so once it is an aromatic compound, another thing which children make a mistake is when they write, you should teach them that when they write the benzene ring and they put a substituent on the benzene ring, every substituent which is put on the benzene ring, it is in place of a hydrogen. So this, when you write, it is actually C6H5CHO. Up to here, it is okay. But if you put Cl here, then what does it become? It becomes C6H4CHO and then Cl. So every time you put a substituent, it is in place of hydrogen. So you keep reducing that. So C6H7O. So for C7H6O, you subtract CHO from here. So you will get C6 and H5. So the moment you write C6H5CHO, the rest of the reaction is solved. So 2A plus NaOH gives X and Y. So which reaction are we talking about? We are talking about Cannizzaro reaction. So rest of it, if you read, you can find out easily. If you still don't get the product in the beginning, by the time you read this is also asked, the similar question has been asked twice, the same question in ISC. Rarely questions are repeated of this type, but this particular has been asked 2 times. So name the product when A is reacted with alcoholic potassium cyanide. So when you think of alcoholic potassium cyanide with a compound containing oxygen, you should immediately think of benzoin condensation. So when it is benzoin condensation, there's only one compound which undergoes benzoin, that is benzaldehyde. So like that, you can find out. Then this is another one, organic compound X that has molecular formula C3H6O2. On acidic hydrolysis, it forms 2 compounds, Y and Z. Y gives a wine red coloration with neutral ferric chloride. Identify X, Y, and Z. The moment you see wine red coloration with, so you know it is acetic acid. So this is acetic acid, CH3COO. Subtract this from here, you will understand it is an ester, CH3COO C2H5. Okay, it is, yeah, this is the other thing is they should be able to look at the molecular formula and guess what is a different type of compound it could be. They don't give very complicated ones in ISC, but by looking at the molecular formula, they should figure out the general formula. Give them a practice of general formulae. All the general formula, they should know the general formula of an alcohol is CN. Like you start from alkanes, so CnH2n plus 2, they have learned all this. CnH2n is for alkenes. CnH2n minus 2 is for alkynes. Then CnH2n plus 2O is for alcohols. CnH2n 2NO is for aldehydes and ketone. Then CnH2n O2, it is for acids. So it is for acids, and this is for acids and esters, right? This is for aldehydes and ketones, right? And this is for alcohols and ethers. So this way, if you just give them a list before doing this, they will be able to identify. So this you should do towards, a little later, when the children have really become very, very, confident of conversions, because this sometimes comes in along with the, in the reactions where they are, the question where they ask this one, they generally give a choice. So if they are not able to do this, they will always have a choice. So at least the brighter ones, you can focus, then they can do this type of question. Give them a little practice. Do very, very simple ones first, and then you should be able to do the remaining. Now here, this is a reaction which, if you go through it, many of you will be familiar with this reaction, but it was asked in 1998. Till that time, our ISC question papers used to be of a very high standard. So this is from an ISC question paper. When I read the question paper after the exam, I still remember, I just couldn't figure out what this compound is. But you should read the whole question. And in this case, you come to the end, the last part, molecular formula of E is C3H6O, right? And it is prepared by heating B with calcium hydroxide. So B is acetic acid, CH3COOH, and with calcium hydroxide, it gives you CH3COO whole twice Ca, and that on heating gives you acetone. So once you reach acetone, then you can start working backwards and you will be able to understand what the organic compound A is. Actually, this was a very difficult question. Organic compound A is actually here. Acetic anhydride with ethyl alcohol. But I will not go through this one, because now acid derivatives are not in our syllabus. So this question cannot be asked. This was asked in those days when we used to have acid derivatives also in detail. So this is the reaction. But why I took it to share with you is because I wanted to show you that this was the level of organic chemistry that we were teaching, and the questions were asked in those days. But now it is much simpler. So when it is simple, let us keep it simple, but let us not dilute it further and make an effort that children should be able to do. Those days also children were doing. So now also children will be able to do. It's not difficult. This is of course not in syllabus. You can change this question slightly and adapt it to the type that would fit in our syllabus. So there are such questions which I picked up from the old question papers, which you can use to do it. So these are the 3 types of questions. I will share this with you with some more ABCD type of questions. And if you have any doubts, please ask. See, it is all about lot of practice. All of you need to put in a lot, make lots of simple. Start with very simple worksheets. In fact, when you, tell the children in the class, all of them, they should make 5 questions on conversions and come to class. First, teach them those 7 methods and ask them to write 5 questions. Then let them ask each other. Have a free day for yourself. Children will make questions, others will answer. So that also helps a lot. So you can do that also. So, sir, since your session was so complete that there is no scope for any doubts. So I think we can close now. India is also about to win. I think we have also won.
The final product will look on YouTube. It has to go up there. So yeah, so I was just penning a few things down to thinking what to say. So, one of the best profound thoughts that I have ever come across from a teacher. He was a doctor, passed away a few years back. He was a director of a school here. He said that the students' learning is only a byproduct of the teachers' learning. And I think the chemistry teachers here will probably understand that much better than anybody else. When you say that for a student to learn, the important thing is that the teacher learns first. So when you know your subject, your students will automatically come to know this subject. And as Vijay sir mentioned, we never really know the kind of impact that we have in the lives of others, and especially in the life of our children. Whether we accept it or not, this has a great impact on the overall education of our country. And this change will take care. We are part of a change. We are slowly trying to change the system. And this will take a lot of time. It will be slow and it will be steady. And without 1 or 2 people can't do this, but I think we are 30 of us here. I think 30 of us can definitely make a change. One request that I have is that we come out of our shells and we ask more questions, we engage more in discussions and in answering questions, even if we think or we fear that we may go wrong. That doesn't matter, which is the whole point of this forum, that we set aside our inhibitions, we come together and we learn and we empower each other. And most importantly, we urge you to spread the insight and the wisdom that we gain here, not just to your students, but to other teachers too. Yeah? Thank you. I know there's a cricket match on, and that you took off time during on a Sunday to come here. We will stay in touch via WhatsApp. Thank you and good evening to all of you.
Thank you, sir.
Thank you, sir.